Good afternoon to you all. With the last class, we completed the chapter States of Matter. And today, we are starting our new chapter, which is Redox Reactions. And in this session, we will be studying about the classical idea of redox reactions, or the basic idea about what is actually redox reactions. So moving on. So looking at the name, you can see two words here, RED as one part and OX as one part. So this RED part tells us there is involvement of reduction reaction, and this OX part tells us that there is involvement of oxidation in this reaction. So overall, redox reaction means that there is involvement of reduction reaction and oxidation reaction together. So that's why we call them redox reactions. And redox reactions are type of reactions which are very important in chemistry. And most of the reactions which we deal with in our NCERT textbook are redox ones. And they do have a lot of applications, both physical and biological. Now we will discuss some fields which redox reactions are involved. So as we told, a number of phenomena or number of fields, both physical as well as biological, are concerned with redox reactions. So many of the fields are using redox reactions, and we will see few of them. First one is pharmaceutical. So pharmaceutical is a field where the production of medicine occur. So production of one medicine will need more than 100 steps or 100 reactions, and most of them will be redox reactions. So next field is biological field. Many number of reactions which are involved in our body or human body, even the plant body. For example, if we cut a fruit and keep it outside the air, the color of the fruit changes, right? So similarly, that is also a redox reaction. Like that, there are a lot of reactions or biological reactions in which this redox are involved. Industrial, there are a lot of industrial fields like pure chemical industries and paint industries. So all those needs redox reactions to the maximum. So metallurgy is the purification of metal from its ore, or ores of metal like bauxite is converted to the pure metal like aluminium by different types of reactions and processes. There also hundreds of processes are involved in purification. Many of these purification techniques are redox reactions also. Next field is agricultural field. In agricultural field, we have production of fertilizers, insecticides, etc. And they are also involving a lot of redox reactions. More than this, there are a lot of fields like burning of fuels in the fuel cell, then batteries, many electrochemical processes, all those, and even the holes which are produced in the ozone layer, that is also a redox reaction occurring. So there are a lot of redox reactions around us. So now we are going to do a comparative study of oxidation and reduction. So as we know, oxidation is just opposite of reduction and vice versa. So oxidation and reduction is defined in four methods, or four definitions are there for oxidation and reduction according to classical concept. And this is an old concept too. It's an earlier concept which is known as the classical concept. So we are going to discuss that. So the first definition, oxidation is the addition of oxygen to an element or a compound. So when we add oxygen to an element or a compound, that reaction we can tell it as oxidation. And just opposite of that, reduction. Addition of hydrogen, not oxygen, addition of hydrogen to an element or a compound. So oxygen is an electronegative element and hydrogen is an electropositive one. So in oxidation, as the name suggests, the oxy, so the addition of oxygen is happening there. In reduction, we have addition of hydrogen to an element or compound. We will see examples. So here Mg or magnesium plus oxygen gives MgO. Here with magnesium we are adding the oxygen. So we get MgO. As we are adding oxygen to an element, we can tell this is an oxidation reaction. Even in this case, the same reaction. With sulfur, we are adding oxygen. So sulfur plus oxygen gives sulfur dioxide. So there also addition of oxygen happens. So we can tell that's an oxidation reaction. And when we go to reduction, there you can see this reaction, which is an ethene. The alkene is taken and added with hydrogen, so that one of the double bond is removed and one hydrogen is placed in this one and one is placed in this one. So in both the places we are adding 1 hydrogens. So we get CH3 single bond CH3, which is ethane. So one alkene is converted to alkane here, and in this reaction the addition of hydrogen is happening. So that's why we call it as reduction. In this case addition of oxygen, in this case addition of hydrogen. Now we will see the second definition of oxidation and reduction in the classical concept. So removal of hydrogen is oxidation and removal of oxygen is reduction. So they are complete opposite. Here addition of oxygen and removal of hydrogen. In this case addition of hydrogen and removal of oxygen. So here we have the reactions. Here we have taken methane. Methane plus 2O2 oxygen, which gives CO2. But with addition of oxygen, there is removal of hydrogen also. So from CH4, from methane, the methane molecule loses the 4 hydrogens and addition of 2 oxygens happen there. And the hydrogens are added with oxygens to form H2O, or the water molecule. So with methane, removal of hydrogen is occurring. So that's why oxidation can also be told as removal of hydrogen. In this case, the mercuric oxide is converted to Hg plus O2. Here, removal of one oxygen is happening there. So in one place, removal of hydrogen, in this place, removal of oxygen. So that is the second definition of oxidation and reduction. Now we will go to the third definition. Addition of electronegative element. Here, addition of electropositive element. So when with an element or a compound, if we are adding an electronegative element like fluorine, chlorine, etc., then we can tell it's an oxidation. And if we are adding a electropositive metal or electropositive element like metals, we can tell it's reduction. So the reactions, Mg, the magnesium plus fluorine gives MgF2. So here fluorine is an electronegative element. So combining with magnesium, magnesium is getting oxidized to form MgF2. So as electronegative element is adding with Mg, we can tell magnesium is getting oxidized to form MgF2. Same when we add chlorine also. So Mg plus Cl2. Cl is an electronegative element. So an element plus an electronegative element to combine them, which means an oxidation reaction. In case of reduction, HgCl2. So Hg, the mercury, is an electropositive element. With chlorine, in the reactant part, it is HgCl2. In the product part, it is Hg2Cl2. So one more Hg or one more electropositive metal is being added to chlorine. So we can tell Hg is becoming reduced to Hg2Cl2 as an electropositive element is getting added. So addition of electropositive element is reduction, addition of electronegative element is oxidation. So will be confusing to remember all this. So I'll tell you, oxygen and hydrogen you can remember. So addition of oxygen, oxygen is an electronegative element. Removal of hydrogen, here also a positive is getting removed. So we can tell oxidation is totally negative. So here also electronegative, here also removal of positive, here also addition of a negative element. So oxidation is a totally negative process. In case of reduction, it's a totally positive process. Hydrogen is positive, removal of an electronegative one, so that's also becoming positive. Addition of electropositive element, that is also positive. So all of them are positive. That's how you can remember these definitions. And the last definition of classical concept you can only guess. So here addition of electronegative element and addition of electropositive element. Just opposite of this will be in the next definition. So that will be removal of electropositive element. There it was addition of electronegative and removal of electropositive is oxidation. So there also you can see removal of electropositive. There also the negative factor is enhanced. Here the removal of electronegative. Here also the positive factor is involved. So reduction is all positive. Oxidation is all negative. This is just for the understanding I am telling you. So now we will see the reactions. 2K4FeCN6 plus H2O2 gives 2K3FeCN6 plus KOH. Here K is an electropositive element or a metal. So potassium is electropositive, and in the product on the reactant part it is K4FeCN6, and in the product part it is K3FeCN6. So one potassium it is getting removed from the whole complex. So that's why it is the removal of electropositive element from a complex or substance. So that's why it's an oxidation reaction. In reduction reaction, 2FeCl3 plus H2 gives 2FeCl2 plus 2HCl. Here removal of electronegative element, which is chlorine. So chlorine is an electronegative element, and in the reactant part we can see 3 chlorines, and in the product part it is just 2 chlorines. So FeCl3 is converted to FeCl2. So, so the reduction part removal of electronegative, and oxidation part removal of electropositive. Oxidation and reduction occur together. Oxidation can occur only when there is reduction, and reduction occurs only when there is oxidation. It is similar to that of a wave. So when there is a crest, then only there is a trough. So if there is no crest, there is no trough. If there is just a trough, then it will go in a straight line, or if there is a trough also, it will go in a straight line. So only when there is a crest, there is a trough. So similarly, when there is oxidation, then only reduction will be there, and when there is reduction, then only oxidation will be there. So they occur only together, even they are opposite. This is the redox reaction which is given here. So we need to find where is the oxidation and where is the reduction occur. In case of H2S, in H2S the chlorine is getting added to it and forms HCl, and sulfur, the hydrogen is lost and it is forming just sulfur. So in both the cases H2S is getting oxidized. So chlorine is an electronegative element. So addition of electronegative element will becomes oxidation. So H2S is getting oxidized to form HCl and sulfur. In case of chlorine, chlorine is getting reduced to form HCl. So with the chlorine, one hydrogen is getting added. So addition of hydrogen is reduction. So chlorine is getting reduced to form HCl, and H2S is getting oxidized by addition of chlorine and by removal of H2 in case of sulfur. So H2S is getting oxidized and chlorine is getting reduced. So oxidation and reduction is coming together. So we can tell it's a redox reaction. Next we will see another example. Fe3O4 plus Al gives Fe plus Al2O3. In this case also Fe3O4 is converted to Fe. Iron is losing oxygen, so removal of oxygen is reduction. So Fe3O4 is getting reduced to form Fe. In case of aluminium, aluminium is getting added with oxygen. So addition of oxygen, which is oxidation. So aluminium is getting oxidized to form Al2O3. So Fe3O4 getting reduced to form Fe, and Al is getting added with oxygen to form Al2O3, which is oxidation. So oxidation and reduction is combining to form this reaction, hence it is a redox reaction. You need to explain this well in the notes also. So with this we conclude our first session. Be clear with that by reading the textbook also. Next day we will study about reducing and oxidizing agents and another method, and method which is other than the conventional or the classical method we will study. So prepare notes and submit. Thank you.